So how you doing folks? Today we're going to be taking a look at the SEGA Mega Drive or Genesis and a Jailbar fix. So if you're on a CRT you may not notice the jailbars as much, but once you start going into modern displays or capturing, you're going to notice jailbars a lot. So we're going to have a look at the jailbars first. I'm going to be using the RetroTink 5X and the StarTech USB 3 HD capture device. And we'll take a look at the jailbars and then we'll come back. So using Sonic the Hedgehog 1 for demonstration purposes here. So during the intro, what we'll do is we'll pause a frame, and if you look above Sonic's ear and just above his finger where he's pointing, you can clearly see those jailbars. Going back to the demo, in the attract mode, if we pause here, you can see again in the background that jailbar pattern. Pausing it just makes it easier to see, but they can be quite visible depending on the colours on screen. So now we've had a look at the jailbars and what they look like, I'm going to introduce you to this little guy. This is the triple bypass. I think it was originally worked on by Renee from DB Electronics, but this is version 2, so it's probably had a couple of redesigns, but these are really cool, and it seems to be the one folks go for when they're bypassing the video and trying to get rid of those jailbars. We've also got a little mini DIN here. This is the same one that you'll see on the back of the SEGA Mega Drive 2 and a couple other consoles, I believe. So these are what we're going to use to get rid of our jailbars, hopefully. So first, let's take the console apart and have a closer look. So with the top part of the case off, you can see inside the console, and this has had a fair few repairs and some modifications. So when I first got the console, I needed to fix up some traces here and down by the Z80. It's got an Arduino Nano Mega Drive Plus mod in there. And an NTSC crystal oscillator. I also replaced the cable assembly over here for the power. It had been cut, so I added a new one. Soldered on back the stereo jack that had been cut off. But if we remove the screws, we can take a look at the bottom side of the board. So looking at the bottom side of the board, you can see some bodge wires going to the edge connector. That's from the original repair. There's a small red wire there as well by the cartridge port, and basically that had to be done because when I replaced the cartridge slot, I originally used a third-party one, but I went with one from the spares board instead. It grips the cartridge much better. With that said, we have to remove the two screws holding the heatsink to the board. Those screws removed, we can remove the ones from the actual voltage regulators going to the heatsink. So we can clearly see the board now, and looking over here we have the VDP, and we'll be pulling our signals for the mod from there. But first we've got to remove this RF modulator. That has to come off because we're going to be mounting our mini DIN. So to remove it, I use both the desoldering station and my iron just to give me a bit more thermal capacity. I first added some leaded solder to each one of these joints to make it easier to get off. What I wasn't able to catch on camera here is that I actually, once the solder was gone, I rocked the pins, as you can see here, but then I actually got in under there with a tool, and by heating each leg on one side and then the other, I was able to walk the RF modulator off the board without kind of doing any damage. Sometimes these are easy to get off, sometimes you've got to kind of walk them off the board. So with that done, we've got to size things up for mounting our mini DIN. So if we try and line it up first with the hole, and then we're going to scrape away the solder resist and solder directly to the board. Now, getting these to fit properly means that you can't have a great connection going from the actual board to the mini DIN because it pushes it to the left away from the hole. But if you lift the board up, the small board up ever so slightly, you can get it to line up pretty much perfectly. So it's worth mounting the DIN before you do that to the board. You'll have good electrical connections there. And to be fair, it's the DIN that has to have the solid connection to the board. The actual PCB shouldn't really be dealing with any kind of mechanical stress, so long as there's a good electrical connection there. It's the a strong mechanical connection is more for the mini DIN. This little board should be fine. It's not going to really see the same stresses. So marking it out with a pen, and then remove the DIN. And then I chose to use a scribe, and I'm going to make it just ever so slightly bigger than it needs to be. So I first started with a scribe just to get the initial outline, and keeping it clean throughout using cotton bud and some alcohol. I tried a razor from like a larger kind of a craft knife, and I also tried my scalpel style craft knife, which seemed to do the best job. And I kind of stuck with that for a good while, again keeping it clean. I also tried the fiberglass brush, not really that great. It worked towards the end for kind of getting rid of that final kind of oxide layer before putting down flux and solder, but the craft knife seemed to be the best kind of solution for it. So just going slowly, only revealing as much as you need. So with that area done, I decided to reveal a bit more between those two vias because they seem to line up pretty much with the center of the board. Seemed like a good place to rest the iron on. So I got rid of more of the solder resist up there and just kept it clean. So now that we have the area prepared and the solder mask removed, it's time to get the DIN on. So we're going to start by adding a little bit of flux. You can put on a healthy enough amount. And we're going to spread it around using a cotton bud. The idea here is a trick I picked up from mounting MOSFETs, is that the inrush of hot solder will displace the flux, and that way you get a good wetted joint between the two surfaces. So the board itself is going to have a lot of thermal mass, so after loading up your tip and making sure your alignment is okay, don't be afraid to hold the iron there for quite a bit in order just to get that initial tacked on joint. Once the piece is fully tacked on, we can take it back out of the case. Once we're happy with the alignment and we have that initial kind of just the DIN tacked on, take it out of the plastic, and we can work on it outside the case. So again, flux is your friend. So now that I've initially kind of tacked, I'm going to try and get a bit more of a better joint going here. So again, let the heat soak. What you want to see is that flux coming out the side. Be sure to move the iron around so you're spreading the heat across the entire joint. And what you really want to see is, you can kind of see it on the right hand side there, you want to see the flux coming out the sides. That means solder has penetrated through. With a cotton bud and some IPA, and go for a good clean up. So that's our DIN on. It's not the easiest, but take your time and use plenty heat and you should be fine. So let's have a look at the triple bypass board, because we're going to need to configure some jumpers before we mount it to the mini DIN. These can be found on the rear of the board. Since this board is a Model 1 with a YM2612, we're going to solder both the number 1 jumpers marked. If you have a later revision console, you'll need to look and double check the table on the silk screen on the rear of the board, because you'll have to use separate jumpers. While we're here, we're also going to set the low pass filter. So next we're going to mount the triple bypass board to the DIN. Remembering we have to lift it up slightly for a good fit. With a small tip on our iron, we're going to start by tacking on one solder point. This will allow us to reposition the board. We need the solder to flow through onto the pin well, so we're going to add flux to make our life that much easier. Clean and inspect the work, touching up any joints that look like they need it. Before soldering the last larger points, and while we have a small tip on, we're going to move on to the VDP. Here's the Visual Display Processor, or VDP, on this VA4 console. It's a SEGA part number 3155313. This is where the bulk of the work for this mod is going to go down. Be sure to Google your part number of your VDP, as it may vary and the pins you'll need to tap will be different. With that said, here's an image of the points we're interested in for this revision VDP. Note, I want this mod to be as non-destructive as possible, and I'd also like to retain the functionality of the original DIN. So we're not going to lift any pins if we don't have to. We'll solder to the vias instead. So let's get started by tinning those vias. I'm going to be using 30-aught Kynar wire. It might be better to use stranded wire, but this single core Kynar is the only 30-aught wire I have at hand. Once the wires are attached, I'm going to coax them into place and tape them down to the board for now. For the analog power and ground, I'm going to go for a slightly beefier 26-aught stranded wire. I stripped and tinned the wire to make my life easier, along with adding some flux to the end before soldering it in place. Switching back to the 30-aught Kynar, we're going to do the same for the C-Sync signal. With our wires attached to the board, we'll spend some time coaxing them into place and taping them down temporarily to keep them neat. Once they're tidy, I added a small drop of superglue to keep the wires bunched together. Once that dries, you can start to wrangle them into place and solder them up. Take your time, put on a podcast, listen to some music. There's really no rush. With the glue set and the wires terminated, we can remove the tape. Remember, we're not gluing the wires to the board, just to each other. With the finer solder work done, I switched to my larger tip so we could go back and hit those solder joints we left earlier on the actual bypass board. With those done, it's time to turn our attention to the audio section of the triple bypass board. First, we'll tin the pads. For the audio, we're going to go with some 26-AUG stranded ribbon cable. I forgot to capture it, but on a VA4 model like mine, we're going to need to remove some through-hole capacitors. So we're going to remove C40, C41, C42, C43 and C44. We're also going to remove C61 and C62. This will have the effect of disabling the audio from the stereo jack at the front of the console, but we'll do some stuff later on to restore this. We're going to peel away an individual strand as we need it from the ribbon to keep things neat. We'll keep our runs as short as possible. tinning and using flux just like before. So it's advised that we lift the subcarrier pin on the VDP, that's pin 50 in my case. First however, I'd like to test it out and capture some footage before we lift pin 50 so we can compare results later on. So the results already look good, but let's lift pin 50 and see what difference that makes. Before starting, I double check I have the right pin twice. Once I'm happy, we get started by applying some flux to pin 50. Sorry for the poor angle here, but it was hard to capture this on camera. So grasping the pin with a fine tipped tweezers, I'm going to heat the pin and the pad while we gently lift it out of circuit. Now with the subcarrier pin out of circuit, let's see what the difference is. So I think our colour is looking a lot better, with what looks like to my eye a broader colour space. You can see this clearly in the blues and brown tones on the Sonic title screen. So that worked out good, but what about the original video connector? Well, let's check that out. We still have jailbars and in general a noisy signal. It's a lot better due to the subcarrier pin being lifted, but not as rich as the new bypass signal from the mini DIN. And as expected, we have no audio. To fix this, we could pull audio from the stereo left and right channels on the triple bypass board itself. This does mean our volume slider at the front won't be functional. So after experiments with connecting the audio to the Sony CXA 1034p stereo amp, with less than desirable results, I decided to do just that and connect the front stereo plug to the output at the rear of the triple bypass board. We lose the volume slider, but we have stereo audio with the original DIN. We might return to it in the future if I can find a good way to tap into that Sony stereo amp chip. And if you have any suggestions, feel free to leave them in the comments below and I'll definitely give it a try. So I'm concerned the video is still noisy. We still have jailbars and I expected the picture quality to be a lot better. First, I removed the connection to the stereo jack, suspecting that it might be acting like an antenna. Needless to say, that didn't really help. Off camera, I had tried using heavier gauge wire on the RGB signals, and after noticing that the VDP was getting a little warmer than usual, I decided to pull power directly from the 7805 voltage regulator. Tapping power from the voltage regulator worked, but the larger gauge wire for the RGB lines didn't really deliver any results. So I decided it was time to break out the scope. For this, we're going to use the EverDrive running the 240p test suites test patterns. I soldered wires to the triple bypass board to attach the probes to the blue channel output. Not the best solution, but I tried to keep them short. Using a solid blue test screen, if we take a look at the scope, we can see there is a lot of intermittent noise near 0 volts or ground. Keep this in mind, we'll come back to it shortly. After reading up some more on Retro RGB's triple bypass guide and some other forum posts, I decided to reinstate the subcarrier pin 50 of the VDP. Out of circuit, it would cause some issues with peripherals like the 32X or maybe even the Mega CD. So turning our attention back to the scope again and that noise around 0 volts or ground, this seems to be the source of much of our jailbars and general kind of noise in the video signal. So I decided to lift the RGB pins of the VDP and add capacitors to try and reduce that noise. I was trying to avoid this originally. I wanted to retain the old connector, but in order for this mod to work, I think we're going to lose the functionality of the old DIN. So with the RGB pins lifted, I added the capacitors to both the analog and digital voltage supplies of the VDP. The largest capacity ceramic caps I have are 220 nanofarad through holes. Most installs I referenced used 4.7 microfarad surface mount MLCC caps, but I decided to just go with what I had at hand rather than wait around for parts to arrive. Soldering to the pins of the VDP isn't easy. I used 30 odd Kynar wire again, covering each pin with a small piece of Kapton tape after soldering, so it wouldn't fall off when I heated the pin next to it. With the wires attached to the pins, I routed it towards the triple bypass, using a tiny amount of super glue again to keep the wires neat. Soldered them up to the board, so let's see the results. SEGA! Instantly we can see that we've gotten rid of the majority of the noise in the video signal. It's never going to be 100%, but this is very close. Larger capacity caps might help, but I'm delighted with the results. In this before and after comparison image of the Sonic the Hedgehog title screen, you can see in the stock video out on the left those jailbars, whereas on the right, completely gone. Also, the image on the right from the new triple bypass, there just seems to be a better colour range, and especially in the darker tones. So we've taken a look at the Sonic, which we've mostly been using to test, but we've also been looking at the 240p test suite. But yeah, let's change it up. We're going to put on one of my favourite games, Shinobi 3. Shinobi 3 is a very good looking game anyways, but I'm really digging it with this new video out from the triple bypass. In the end, in order to get rid of the jailbars, I had to compromise. I had hoped to retain the functionality of the old DIN, but in order for us to get that good signal, we had to lift those pins. That meant taking the old DIN out of circuit. Now you could desolder that DIN, it's probably a good idea. It would make installing the triple bypass board a little bit easier. I think the solution for the front headphone jack is to just get a nice piece of shielded phono cable and run that from the triple bypass board to the actual headphone jack. I'll continue to look in to see if I can tap the Sony stereo amplifier chip so that we can use the volume slider on the board, but that'll be for a future project. So that's been our look at the triple bypass board and a jailbar fix for the SEGA Mega Drive. Thanks for tuning in, and I'll chat to you all again.